So diving right in here, concepts that we have to talk about is what number changes the amplitude, how is our period length affected, and then we're going to talk about the idea of our phase shifts, whether it's a vertical shift or a horizontal shift. So the big concept that you need to understand is this right here, and it works for cosine, not just for sine. And what I mean by that is the number that is in front of the trig function is going to be the number that changes the amplitude. The number that follows the sine or the cosine is going to change our period length. And then inside the parentheses is going to be our horizontal shift. Okay, and then the number at the end is our vertical shift. Okay, in this middle part here, okay, understand that there may be a chance, okay, when we get to it in more in depth, that we might have to actually factor out the b value so that we could figure out what the period length is. So kind of think ahead a little bit there. Also reminder that the number in the parentheses, remember, is always your opposite. Okay, so like if it says minus, then it's actually shifting to the right, to the positive. If it's negative, it's shifting to the left, and that's going to say a plus sign because when you subtract a negative. But then your vertical shift is what it is. So if it says plus 3, it goes up 3. If it says minus 4, it goes down 4. Okay? All right, so just some reminders there. All right, a couple of key concepts. Number one, the first one here is the period value is determined by taking 2 pi divided by b. Why 2 pi? What does 2 pi represent? One full circle, or your period length right now. Okay, your parent's function's period length is 2 pi. Okay, and so the b value is going to change that. That means it could possibly decrease it if b is a number greater than 1, or it could increase it if it is a number less than 1. Okay, then you've got your horizontal shift and your vertical shift. And, you know, when we get to period length for tangent, it changes just slightly, but we're going to do an entire unit on tangent. As of right now, we're just focusing on sine and cosine. Okay? All right, so big idea here is just make sure you understand what the A, B, C, and D value all do. All right, so let's just dive right in and practice this. Okay? All right, so what does this 3 mean? What does it do?
That it goes up to 3 and goes down to 3.
All right, very good.
Negative 3.
All right. So yesterday I said try and focus on your 5 major points for a sine curve and a cosine curve. All right, so what I mean by that is let's just go ahead and get our, graph set up with our 3, 2, 1, -1, -2, -3. Okay? All right, so there are 4 points out here. The 5th point is going to be the point that is on the y-axis. So to start, where does the cosine curve begin? Does it begin at the origin, or does it begin at, like a different value? Ashley?
It begins at the top since it's cosine.
Okay, so one of our points is going to be right there at 0, 3. Okay, then we should have a point right here, and this point is pi over 2. Okay, and that is going to be one of our x-intercepts. Then we're going to go all the way down to a value of -3. That's going to occur at pi. Then we're going to come back and cross the x-axis. That is going to be at 3 pi over 2. And then we're going to finish our curve so that we have one complete circle at 2 pi. So our period length right now has stayed the same because our b value is 1. There is an invisible 1 in front of our theta value right there. Okay, so 2 pi divided by 1 is 2 pi. All right, and then if we just connect the dots, we get like this little U-shaped curve. Okay. All right, so questions that may be asked, beyond just graphing. Number 1, can you tell me what the x-intercepts are? It's very simple. Just read them off the graph.
Pi over 2 and 3 pi over 2.
Pi over 2 and 3 pi over 2. Done. okay? Then, based upon like questions that were asked from last night's homework, where is our graph increasing? Can you give me an interval for which it is increasing? Yeah, Evan, say it again? Pi to 2 pi. So we're going to go parentheses pi, comma, 2 pi. And remember, when we're talking about where it's increasing, we're talking about the x values, not the y values. So don't tell me -3 to 3. Give me pi to 2 pi. So we're talking about it's increasing on, you know, in terms of a horizontal value. Okay? Questions there? Okay? So in general, you're graphing 5 points where it starts, okay? And then your pi over 2, your pi, your 3 pi over 2, your 2 pi, okay? And so that's why if you really understand your parent functions, it will be easy, okay? Now what's going to make it more difficult is when we get to different period lengths, but we'll talk about that, okay? All right, second one, you got -5 sine theta, okay? So amplitude is going to be?
-5, or 5.
It'll be 5, okay? What's the negative going to do?
That's where it starts. Or no, that's, I don't know.
Okay? What's the negative going to do? It's going to flip our sine curve. Where does our sine curve begin again, Anthony? At the origin. So instead of our sine curve going up to begin, now it's going to go down to begin, and then it'll finish on an up value. Okay? So we have a 5 here. We have a -5 here. Okay? So, you know, label that in terms of your graph so that we see that you understand the concept of amplitude. You got 5 points. Okay? You have one that is going to be here. We know that it's going to go down. It's going to come back up. It's going to come all the way to the top. It's going to come back down. Okay? Understand that this is pi over 2, pi, 3 pi over 2, and then 2 pi. So get in the habit of labeling both your x-axis and your y-axis. And then when you go to connect the dots, you've got your sine curve. Notice that it is upside down because of the negative. Okay? Questions on that? Again, questions that could be asked are, what are the x-intercepts? You would label 3 of them, 0 being one of them, and then the other 2, and then where is it increasing? Okay? All right, so now we get into our very first shift, okay? This is going to be a vertical shift, okay? So a couple of ideas. Number one, if you want, we could start by just graphing the parent function and then shift it, okay, if you want to do it that way. Or if you think you understand it, what is the 6 going to do? Yeah. Shift it up. So what's our lowest value right now for the parent function? So what's -1 plus 6? -1 plus 6 is -5. +5. So therefore, we know that the bottom of our graph is going to be at 5. What's the top of your parent function? 7, because of 6 plus 1. The parent function is 1, and then plus the 6 is going to be at 7, right? Your middle of the graph is going to be at 6, because would you agree that the amplitude is still 1? Okay, so our cosine curve. Well, are there any questions as of right now? Okay, so if it helps, think about doing this, okay? I am just going to draw like a new x-axis. I don't know if this will help, okay, but maybe. This is kind of like your midline, okay? It's the line that passes halfway through your cosine curve, okay? Reminder that since our period value has not changed, we're still at pi over 2 is one of our values, pi is one of our values, 3 pi over 2 is one of our values, 2 pi. Those are the 4 points that we want to be able to make sure that we graph, okay? All right, so where do we start at for cosine?
7.
We're going to start at the 7. Very good. When you get to pi over 2, where should it be?
6.
At 6. When you get to pi, it should be at 5. At 3 pi over 2, it is 6, and then 2 pi, it is back at 7. So you should have a curve that looks like this, okay? And if you compare it to the one right above it, okay, notice that all we did was we took that curve and we just shifted it all up, okay? So if drawing that midline helps, think about doing that way. If you wanted to, what you could have also done is, graphed from 1 to -1, and then from there, just shift everything up 6 points, if that helps as well. Questions there? Okay. You want to try the last one on your own? See what you can do on that one. So the discussion that is being had right now is some people are saying, think about the fact that you have a -1/2 and a 1/2 being your basic amplitude if we didn't have the -2. Now that we have a -2, what is the top of the graph going to be at? What's 1/2 minus 2? I hear a lot of whispering. What's 1/2 minus 2? -1.5. So we're at -1, we're at -1.5. That's the top of the graph. The middle of the graph is going to be at -2, and then the bottom of the graph is going to be at -2.5. Okay, so remember, our midline, our new x-axis is going to be right here. So think about that, okay? And since it's at 2, it's only going to go up a value of 1/2, right? Question?
So how come in the one before this, 6 was the midline, even though it came in the front, and now this is 2 and it's in the back? Like,
Oh,
you know what I'm saying?
okay, sure. That's a great question. So, you know how the 6 in the front and the back, that doesn't matter. Because as long as it's not in parentheses, okay, can't I, based upon our commutative property of addition, write cosine theta plus 6, and wouldn't that mean the same thing?
Okay, so whenever
Okay.
you're adding, that just means that adding or subtracting, that just means that's the new midline?
Yes. So -2 is now our new midline, and then we're going up by a value of 1/2 and down by a value of 1/2. So if, that's a great way of saying it. The number that you're adding or subtracting is your midline number. Okay, and then from there, just understand you're going up 1/2 or down 1/2, okay? Our period value hasn't changed, so still use your pi over 2, your pi, your 3 pi over 2, and your 2 pi. Okay, are we gonna start at -1, -2, or -2.5 for our very first point? At -2, because it's the sine curve. And then remember, it's going to go up. It's not negative, so it's going to go up first. Then it's going to cross the midline again, go down, and then finish back up at 2 pi. Okay? So that one's tough. So concepts to think about. Number 1, understand, like she said, that that's your new midline, and then that's your amplitude. If it does help, think about maybe drawing your parent function first, okay, and then from there, shifting it down, but that's completely up to you. And when you graph your parent function, graph it with the amplitude, and then it'll be easier to shift, okay? All right, page 2. Now we're going to talk about how to change that period length, okay? All right, so remember, the period is basically what it takes to complete one full cycle or one full circle, okay? So if your period value is normally 2 pi, if we divide by the b value, we will get our new period length. So in the very first example here, our b value is a 1, so 2 pi divided by 1 is just 2 pi. But in the second one, we would take 2 pi and divide by 4. What do you get there? What do you get? Pi over 2. All right, so here comes the tricky part, okay? When we go to graph, our ending is gonna be at pi over 2. There are 3 points in between there that we have to graph, because one of them represents, like in the sine curve, the top of the sine curve, where it crosses again, and the bottom of the sine curve before it finishes at pi over 2. How would you come up with those other 3 values? What would you do? So pi over 3, pi over 4, pi over 6. Yes?
Yeah.
Okay. And how are you getting those numbers?
From what we did like last year.
Okay. They're not gonna work in this case because the difference between pi over 3 and pi over 4 are not equal, and pi over 3 is actually greater than pi over 4. So pi over 3 would not be our first one. You had a hand up in the back? No? I'm just curious. Basically, I'm just asking.
Just keep dividing by 2, pi over 4, pi over 8 maybe?
And pi over.
Shut up.
Okay, so what, all right, so dividing by 2, what would that give us? Which one would that give us?
Just,
Would that give us this first
Yeah.
line, the second line, the third line, or what? The third one?
yeah.
All right, how about if I cut that in half by dividing by 2? Wouldn't that give me this one?
Then what would that,
So how would I get the next one?
could you do pi over 3 for the next one?
No, it's not gonna be pi over 3 because the difference between 0 and pi over 3 and pi over 3 and pi over 4 is not the same. What would it be? No, because 3 pi over 4 is greater than pi over 2. You guys understand that pi over 2 is 1/2, right? So we're basically taking a half and cutting it into 4 pieces. 50 cents and cutting it 4 ways.
50 cents?
50 cents, yeah, 50 cents. Okay, yeah. Well, what if we took our pi over 4 and divided that by 2 again? What's pi over 4 divided by 2?
That's a trick question. Just kidding.
How about it's pi over 8, because all you're doing is doubling the denominator. So think about it this way. Now that we know the very first one is pi over 8, okay? Well, 2 pi over 8 is pi over 4. 3 pi over 8 would be the next one. And then 4 pi divided by 8 would be pi over 2, okay? So Anthony's idea of dividing by 2 works, or was that Vinny's idea?
No,
It was yours, okay. But you just have to understand when you're doing that, which one you're getting, and then we're doing it again. All right, so why am I asking that question? Well, here's why. If that's too hard, what we just did there is another way, okay? And this is where the chart comes into play, okay? So let's take our pi over 2 example, okay? Or let's take this example of b being, a 4, okay? If you wanted to come up with the new points based upon our new period length, what you can do is you can multiply by 1 over b, okay? So what's 0 times 1/4?
0.
So that one doesn't change. What's pi over 2 times 1/4? Say louder, what'd you get? And what did we have in our chart? Pi over 8, okay? What's pi times 1/4? Pi over 4, and I believe that was our middle value. And then 3 pi over 2 times 1 over 4 is 3 pi over 8. So far it's working with our graph above. And then 2 pi times 1/4. Hopefully you're going to say is pi over 2. Okay? Because 2 divided by 4 is 1/2. Okay? So these values match these values above. Okay? So that's one way to do it. So I tried to show you how to do it just by thinking it through, and then now there's a more systematic way of doing it, if that's going to help. Okay? All right, so practicing with that. Notice that on this one, there's no amplitude change, there's no shifts. All we're doing is focusing on changing the period length. So what does B equal?
6.
B is equal to 6. So all we're going to do is take each of our basic 5 points from our parent function of the sine curve, the top of the graph, the middle of the graph, the bottom of the graph, the ending point of the graph, and we are going to multiply them all by 1/6, because B is equal to a 6. So going through this, 0 times 1/6 is 0, because 0 times anything is 0. Pi over 2 times 1/6 is pi over 12. Pi times 1/6, pi over 6. 3 pi over 2 times pi over, or 1 over 6 is pi over 4. It's 3 pi over 12, but you can simplify 3/12 to 1/4. Okay, and then 2 pi times 1/6 is pi over 3. 2/6 is the same thing as 1/3. Okay, so now our points are pi over 12, pi over 6, pi over 4, and our graph is going to finish at pi over 3. What is the top of the graph going to be at? What's the bottom of the graph going to be at? 1 and -1. Where does sine begin? At the origin or at 1? Origin. So the very first point we come up to is the top of the graph. The second point we get to is back at the x-axis. The third point is the bottom of the graph. And the fourth point is back at the x-axis to complete our sine curve. Okay? So if you understand those 5 points and how it creates our sine curve, you now just have to be able to figure out our new x values. And so this chart here with the 1 divided by the b value is a very simple, systematic way of figuring it out. Okay? Question?
So the bigger the number, like in front of the x, is going to make it smaller?
Correct. So think about it this way, okay? This 6 basically means that there would be 6 sine curves between 0 and 2 pi. Okay? So one of them is completed between 0 and pi over 3. Another one is between pi over 3 and 2 pi over 3. A third one between 2 pi over 3 and pi. So that's 3 curves just between 0 and pi, and another 3 curves between pi and 2 pi. So that tells us, that's why they also talk about it being frequency. So our frequency is 6. Okay, it means that there's 6 sine curves between 0 and 2 pi. Okay? Other questions? All right, so then we get to an interesting case. This time, what is b equal to?
4 pi.
4 pi. All right. So, what is 2 pi divided by 4 pi? 1/2. So that means our period length is 1/2. So when we go to label our x-axis now, we're not even going to use pi anymore. It's going to be all fractions and whole numbers. Okay? Now, we can still do the exact same thing that we did above. Okay? We can take 0 and multiply by 1 divided by 4 pi. Well, what's 0 times anything? 0. What is pi over 2 times 1 divided by 4 pi?
1/8. Or pi over pi.
Say that again?
Pi over pi, just 1/8. There's no pi.
There's no pi.
So it's 1/8. Okay.
What did you say, 1/8?
Yeah.
That is correct. Okay.
I'm pretty sure I said that like 4 times.
Oh, sorry. You were kind of whispering, mumbling. I didn't. All right. So if you need the, larger version of this, it's pi over 2 times 1 over 4 pi, right? So he did say that the pi's cancel, and then 2 times 4 is 8, so it's 1 over 8. Okay? All right? So 1 over 4 pi is? 1/4. That I heard. Good job. Okay? 3 pi over 2. Whoops. times 1 over 4 pi, 3/8. Okay, and then the last one, 2 pi times 1 over 4 pi is your ending value of 1/2, which we already knew. Okay? Questions with that? All right, so when we go to label our axis, it's just 1/8, 1/4, 3/8, and then 1/2. Okay? Now, recognize that it is a cosine curve. Our amplitude hasn't changed, so it's still 1 to -1. Okay, so where are we going to start this time? At the 1. We'll cross at the 1/8. We'll finish down at the bottom at 1/4, cross at 3/8 again, and then finish back up at the 1/2. Okay? Questions there? Are we going too fast? Do you want to try the next one on your own?
Definitely not.
Definitely not.
Not really.
There's only 3 things going on. Okay? So, for example, let's start with this. Okay? What's the amplitude? 4. So that means if nothing else was going on, then it would go up to 4 and down to -4. But because of the +1, what is it now going to go up to? 5 and down to -3. And if we use, Zoe's idea that 1 is now the new midline, okay, or the new x-axis, okay, now you know it's going up to 5 and down to -3, okay, and that's your amplitude of 4. Question?
To make things easier, can we just change the already drawn line to 1? Or do you want us to keep
No,
that?
I'd rather see the shifting up and down, yeah. Yeah, I think it'd be better this way. Okay? All right, so now, if we've taken 2 things out of the equation already, the 4 and the 1, the only thing that we really have left to do now is the part that deals with the period length, and we just practiced that. So now we just go through, and can anybody tell me what B is equal to?
3 over x.
3 over x. Oh, a little, sorry.
Not 3, what is B? What is B?
X over
X over 3.
B is not 3. B is not 4. B is equal to 1/3. Okay? Since B is equal to 1/3, remember 2 pi divided by 1/3 tells us that our period length is going to be 6 pi. That's going to be our period length. So we're going to end at 6 pi. Okay? So how do we get there? Well, let me ask you a simple question. What's 1 divided by 1/3 to make our chart easier? 3. So instead of multiplying by 1 divided by 1/3, how about we just multiply it by 3? 0 times 3 is 0. Question?
What about the x? Does that not matter?
Well, remember the x is like your theta.
Okay.
So remember how in 7.1 they use t,
Yeah.
okay? In the last chapter they use theta or alpha or beta. X is just your angle measure.
So it's always 1.
So, no, it's just your variable.
Then why is it 1 in this? Am I just overthinking this?
Yes, it's
1/3 x.
it's 1/3 x.
But they just put the.
So they just,
Okay.
so they could have written it like this. 4 cosine 1/3 x plus 1.
Oh,
But
yeah.
instead, they
Yes,
just
yes,
put the
yes.
x in the numerator.
Sorry.
Nope, you're good. Yeah, I think you were,
Yeah,
like you
I'm
said,
really
overthinking it,
this.
okay? What's pi over 2 times 3? 3 pi over 2. Pi times 3 is 3 pi. 3 pi over 2 times 3 is 9 pi over 2. You're great at this. 2 pi times 3 is 6 pi. And remember, that's where we said we were going to end because that's your period length. So one full cosine curve is going to go from 0 to 6 pi instead of 0 to 2 pi. Okay, and now we know how to label our axis. okay? So we've got our 3 pi over 2, our 3 pi, our 9 pi over 2, and our 6 pi. Where does cosine begin? At the 5. And then remember, it's gonna hit our red line at the 3 pi over 2. It's gonna hit the bottom at -3. It's gonna hit the red line again at 9 pi over 2, and it's gonna finish back up at the top. Okay? So you gotta be really good with understanding your basic parent function for sine and cosine. Okay? All right, so that took a little while. Looks like last page is what, blank?
Yeah.
Oh, so we finished our notes. Good.